Hello everyone, thank you very much. I am Tasfam Alamu. On this video, I will try to show you how to prepare field books for different experimental design that is most frequently used by breeders in this style. These experimental design I will try to cover are RCBD, lattice, alpha lattice, and augmented designs. So we use Agricoli, the package called Agricoli, for developing this field book for different experimental designs. So the first thing we do is we should load this package called Agricoli. If you don't have this package, you should install it. So after that, you call it by calling as library Agricoli. And the next step is, it is a good practice always to set the working directory, because when you set the working directory, it is easy to know where you save your output, and also easily you can read your file from the current working directory easily. So you should set the working directory. For this purpose, this is my working directory, so I will set it using set working directory function, or if possible, if you want, you can go here at home directory. In my case, for example, I will go for desktops, and then I will go for data experiment for our training, and then I will go for here the setting icon, then I will set as for working directory. So now I make the working directory, and then the next step will be read the genotype file or the list of the genotypes, especially as a breeder, since we are using a lot of large number of genotypes. It is not a good idea to list here the genotype. Instead, we prepare the genotype list in the Excel file, and then you can import to our environment so that we can read it using read CSV or read DXL, depending on the type of the file format you saved. So now in my case, the file I saved as CSV. So in this case, I save the file as a list genotype rcbd.csv. So I will read it, and then this is a genotype. So in this case, we see we have 20 genotypes. So it is 20 genotypes. So after that, the third step is to list the locations. Especially as a breeder, we use multi environment trial. So in this case, we list the location names we are interested to test our experiments. So here I list, for example, Bakoji and Holata. So you list it, and in your case, if you have 4, 5, 6, or 7, you can list as you wish. So then we list the location, and the fourth step is to create an empty table to save our field book here as this RCBD. And the second part is this one is we use create a new empty table to save our summary for summary table. That's especially for by genotype, by block, or by rep. In that case, it will help us to prepare it make life easy during the sample preparations. This is experience I have observed during my time in AR. So now we will create these two empty tables, and so this is a R script I prepare. So I will explain each of the lines. This is a location, so means I will loop for each location. It means for each location I will prepare the field book. So this is the for loop. So the function that do the design for RCBD or the field book is, we call it design.rcbd. So For this design RCBD, we need as an input the genotype list, the number of replication, the string, or the first step is randomized if you are interested, or if the randomization to be continued, and so like that. So this information necessary, but for your case you can only change here the genotype list, then the rest will be the default. Then after that you will save this one as a dis, and from this dis, if you extract the book part, so it will saved it will show you the Fieldbook prepared by the this function, and then we will save this design book as a Fieldbook, and then in order to attach the location from each randomization, I will add a column name with the name location and the name location, and this name location will come from this. As you see, I say for I from location. So since if I take, for example, Bakoji, so here it will become Bakoji. When it becomes Holeta, it will become Holeta. So my field book will have a column and location. In that location, I will put the Bakoji or Holeta, any other locations. Then the new column I want to add will be inserted before the plots column in the field book. And finally, I will rename the genotype this case because since this is genotype over dollar genotype, so I don't want this name, so I want only the name genotype. So I will change by using the column name function. I will change it to genotypes. And after that, for the preparation of the summary table by genotype by block, I use this dcast function. So this dcast function, you will provide is the field book. It is from this one, and I will give the formula. The formula is I will make it in the column genotype location and genotype, but on the column side I will want to put the block or the rep. So in this manner you can do this analysis. So then the value to be inserted in this as a value, I will consider the plots. So finally this one will summarize, save the summary from my table already created here, and then the next one is a design RCBD will be save the field book created using these functions. So finally, after I analyze all this, after run this function, I will try to save these two files, the summary and the design RCBD in Excel. So I will save it as a list file first, like this, auto design, and then this auto design come here and put here, and then I will use a function called write XLSX, and then I will give the new field name Fieldbook RCBD to be saved in my computer. So this is the whole process, you can do it. So now let us run, create the new table, then I will run it. So it's already done. So if you check for it, for example, here, for example, I have this summary table 1, 2, 3, because this field book, as you see it, the field book have the location, the plot, the block, and the genotype. So this is the arrangement I should do. Then the design RCBD will give you the whole list of the information, the location, the plot, the block, the genotype. So like that, I will have the information for my randomization. So I will save these two as outdis, and finally I will write in Excel file. Okay, until this one is okay, run it. Oh, sorry, this is this one. Okay, and then this we have two files, two list files. This is some prep, and then the other one is the Fieldbook. So finally I will save in Excel, but here you can also make it overwrite true and also row names false. I think it's a good idea to make it. So here, if you go, you will see it here, Fieldbook RCBD. So I can open it, this one, and then if you go to the Excel file and you can check it, as you see it, we have on the Fieldbook I have this one, the location, and then on the summary I have this one. So location, genotype, this is block 1, block 2, block 3. So I have the summary table. This can be used especially in the laboratory to have summarized table to have to weigh your sample. It makes life easy. Okay, this is for the RCBD. So the next one is for simple lattice. For simple lattice design. So in this case, simple lattice design, as you know, we have three informations we need. The first is simple lattice is a square lattice, square, because it have row and column, and the row and the columns are equal. That means you have, for example, 3 by 3, 4 by 4, 5 by 5 type of plots we have. So we have the row and the column. We will have for simple lattice. In the case simple lattice, when you say simple lattice, it means 2 rep, but we will have also triple lattice when you make it 3 rep. So you can say it's simple lattice or triple lattice. Okay, then the same thing here. We do the same procedure what have been done for the RCBD. For working directory, read the genotype list, and then list the location, and then create the MPT list for these two cases, so that the same procedure happen. In this case, the only difference here is we use design lattice. So in this design lattice, the major requirement is the length of this genotype should be a multiple of one number, like 3 squared, 4 squared, and like that, like 25, 36, 49, 81, 64, like that. So it should be like a square. So the replication can be 3 or 2 depending on your interest. If you make it 2, it means simple lattice. If you make it 3, it is triple lattice. But the rest is similar to the one we described in the RCBD design. Here is the summary table, the output. This one is the Fieldbook. Okay, so this is the same thing we do for this also. In this case, we can also check it. For example, if we run, let's run it, for example. Yeah, it is now run. If you see the Fieldbook, this is the one, the output we have. This is the output we have. We have location, plot, replication, and block. So it is a little bit different. Like in the RCBD, we don't have incomplete block. We only have rep. It's considered as block. So in this case, we have rep and block. So here, the summary, we make it here R instead of block. So the same thing will continue. So we reanalyze that again. Okay. So now if you go for the summary, we will have this summary table for each location. Rep 1, rep 2, rep 3, location, genotype will be like this. The next part is the design lattice field book. So it is also collected here. So as a table. So we have 3 replication, 25 by 3 means 75, and we have 2 locations. The total will be 150. So this one, so to save to the computer this, we make it save this to output as list, and then we can run it. Oh, sorry, this one should be changed here, and then we run it, and then we save this in our Excel file. Here also we can add override true and row names false, because we don't need to take this row name, but if you want to take this row name together, you can put it as it is. It is not any problem, but it's not necessary. That's why we should make it row names false. So you can run it, and then here, if you see the field book XLSX is already displayed here, and so we can see how what thing is contained in this field book. Yeah, now here the field book we have for Bokoji, Holeta, and we have plot, rep, block, and genotype. This is, and then the summary will be like this. We have location, genotype, 1, 2, 3 for the block. So this one we can get this result. Okay. So the third design is the same, almost. It's a little bit different, but it is alpha lattice. For the technical issue, you can look on some reference books. But this alpha lattice different from the simple lattice in some aspects. One of the aspects is, in this case, we can accommodate any number of genotype with multiplied by 2 numbers. For example, 4 times 5, 20 genotype, 6 times 5, 13 genotype, 8 times 10, 18 genotype. But this case, also you can accommodate 5 times 5, 6 times 6, like simple lattice. But this one is a little bit, it is somewhat better from the lattice. The lattice, you only have a multiple of the same number, square number, like 25, 36, and 49, something like that. But in this case, you can make any it means like it's not necessary to be square, like simple lattices can be rectangular, like 4 by 5, 6 by 5, something like that. You can have this thing. Okay. So in this case, we will have 2 information to provide for this alpha lattice design function. The first one is the genotype name, as it's already provided as the previous designs, the replication, and here we have K, means the incomplete block design, the incomplete block, or the length of the incomplete block. This incomplete block, usually, if you have a number not square, like 25, 36, the incomplete block, the length of the incomplete block should be less than to the number of incomplete block. It means, for example, in this case, if I have 20 genotype, the incomplete block should be 4, and the number of block should be 5. So here the incomplete block, the length of the incomplete block will be 4. The same thing should be, because the principle here is if you make narrow the block size, means you will be more efficient and you will have more homogeneous. So the reverse is not happen. So you should consider this thing if you are using alpha lattice designs with which is different from these square numbers. Okay, so the other analysis part is almost the same. So we'll continue to analyze. So the same number of genotype I use here also, like from the genotype here. So I can or mpt table create, and then I will run it. Okay, then in this case, if you see here, you have the different information here. What is the different information other than the lattice? Here we have location, plot, we have columns, block, that is the incomplete block, and then genotype, and then replication. So for here the dcast, we need write replication. Okay, so we have different we added additional column, that is the column here. So this column is the incomplete block. So that is why 1 2 3 4 5, and then we have 5, the same thing, 5 block and 5 incomplete block. So we have row and column information here. So here I can run it again, and then finally we'll have this one, the field book as you see it, and you will have the summary like this, summary table. So I will save these two, I'll save these two as a field book. So here I will add also here the information override true and row names false. Okay, so here is the alpha lattices here. So when you visualize this one, the same thing is, this is the Excel file, we have the field book here, and we have the summary table here. So like that we can use for our experiments. Okay. The last and the fourth experimental design, what I wanted to cover this today is the augmented design, augmented RCBD. We call it augmented RCBD design. So this augmented RCBD design, usually we are using this when we at early stage of the breeding program, especially at observation nursery, where in this case we have a large number of genotype or accessions, but we don't have enough amount of seed to make replicator trial across location or across a single place. So since mostly we have a small sample size, so we are not in a position to make it replicator trials. So in this case, what we're gonna do is the new genotypes we are interested will be unreplicated, but we capture the variation of the block using systematically checks. So the checks will be replicated across each block, and we generate the information about each block using the checks, and we estimate the error variance from that, and then we try to predict the adjusted mean of this, all the genotypes, the new genotypes, based on the performance of the check genotypes across different blocks. So these checks will be used. So in this case, we need two information. The first information is the list of the genotypes. The second information is the check, the name of the check. So here I read the genotypes for augmented. So here I have 100 genotypes as you see it. And then I want to list here the checks. Here I put 3 checks, but depending on, you can increase. If you have more checks, it's better, but you can add also additional 3 or 4 checks. So here I consider only the 3 checks. So you can write it like this and list the checks. So list the check varieties. And mostly these check varieties are the most known varieties in your breeding program, the released varieties like that. So you know the performance of these genotypes in your case. So the main interest in this trial is to know the performance of the new varieties. Okay, then here we will have create the list in order, the table, in order to save our field book here. And the function we used in this case is the design DAU from Agricoli. So in this case, we need the information, 3 information is necessary, should be provided to the function. The first one is treatment 1. We call it the check. If you check it, treatment 1, it shows here checks, where I would check. And the second one is treatment 2, the new varieties. So the new variety here is accession genotypes. And then here R is the replication or block. So here I put 5 block. So it means I can divide my 100 genotype into 5, 20, 20, plus the check, 3 checks. So in each block, I will have 23 genotypes. So like that, I can divide my genotypes and distribute across the blocks. Okay, and the rest is the same as that of we have seen in the above Fieldbook preparation scripts. So we will collect the Fieldbook here, and we'll add the location to attach it, and then finally we'll have rename the genotype, and then we save as a design augmented, and here is the Fieldbook will be written here. So let's run it. We read here, we check, read the check or list the check, and we open, we create a new table, and finally I can run it, this one. So if you check it here, you have this Fieldbook for 2 locations. So the Fieldbook will have plot, location, plot, block, and genotype. So we have this one, and then finally I will write this this information into my hard disk. So I will put as an input this augmented, and then as file name I use augmented RCBD.csv, raw name false. So since it is a single file, I can write using CSV, but I can also write it as Excel, no problem. But this one we will save it. So here augmented RCBD is saved here. We can visualize it. So here it is visualized as CSV file, that's comma derivative, that's location, plot, block, genotype. So in this way you can take to your computer. So this is the final point. So today we have seen it for experimental design and how to produce their randomization and summary table for your laboratory seed preparation especially. So this is what I have today, and then we'll see you again in the next video. Thank you very much. If you have any comment and suggestion, please provide, and also if you don't subscribe, please subscribe and share this link for your friends and colleagues. Thank you very much. See you.